Bismillahirrahmanirrahim. This is another video on graphical method of convolution, and in this we will be actually solving practice problem 15.8. So this was the example 15.8 that we solved in the previous video, which is titled 15.3, and I very strongly urge that you must watch that video first before coming into this problem. Anyway, so this is the conditions given there, xt and ht given, and we have to find output. The only difference, okay, we plotted xt, which is ut, and we also plotted ht, which the details of which again have been explained in the previous video. So if you don't understand how did you get this from these terms, you go and watch my previous video titled 15.5 bracket 3. Okay, so these are the two terms that we have to convolute, and we used this formula, that is xz htz. This means that we have to shift the h term. So we shifted this term in the previous example or previous video. Now what he wants is that repeat the example 15.8 using second integral. So second integral of equation 11 is this one, and this means that we have to this time flip the x signal, not h signal. So we have to flip this one. So let's proceed. Okay, so the first step is to change the scale from t to lambda or z. So we've changed the scale. The given was xt and ht. Now we have made it xz and hz, and this variable t has also been changed to t has been changed to z. Okay, now the second step is flip one of the signal around 0. Now since in our case it has been now told that we got to flip x signal, so we'll flip this one. So we flip this around this axis, we turn it left. So this is what we get. Now the name also changes to x minus z. And now the third step is move the flipped signal to a point t. So basically what we do is we change the variable. 0 is made t, and so minus 1 will become t minus 1, and minus 2 will become t minus 2, and the name will also change to x t minus z. Basically we are adding t in all of these. Okay, now the first step is that we now push the signal, the flipped signal with variable changed t, we now push it close to the upper signal, and now in this case you see we are very close to this 0 line but not touching the 0 line. So that means we can say that the range for movement of t is less than 0. So this t has been moved up to a point which is less than 0. So, and since there is no overlap between the two, you can see this signal and this signal does not overlap. There is a gap, small gap, and therefore the output will be 0, because output is the multiplication of the overlaps. So output is 0 for t less than 0. Now let's move it further. We go between 0 and 1. T is now between 0 and 1. And so what is the change here? Now you can see this portion of the signal is overlapping with the top signal. So this one here and one here overlapping, and the movement of t is from 0 to 1. So this t is between 0 and 1, we are not going further. Has overlap, yes. And this is the original formula. 0 to infinity xt minus z hz. In this case, since we have transformed this one or flipped this signal. Now, what is the limit now in our case? Now, if you see these two overlaps has a starting point of 0, but we don't know what is this point here. So we'll look at the lower signal. So the final point is t. So we'll change the limits of integration from 0 to t. The other things remain same. And now we plug in the values of hz is 1 and xtz is also 1. So 1 into 1. And if integral of 1 is t. So this is, we'll get answer t. Even if you put the limits on this, the limit will be t and 0. So the answer will be t. Now we move it further. We have moved this t now beyond 1. So it is between 1 and 2. And now see what is happening or what happened. This one was earlier overlapping, the positive of ht. And now the negative of ht will also overlapping with the bottom signal. So our movement of t is between 1 and 2, between this now. Has two overlaps. This was the original formula. We again modify, we have to, the starting point is 0 and the ending point is this t here. So the integral is from 0 to t. But now there are two multiplications. If you see, one is positive 1 with positive 1 and its range is from 0 to 1. And the other is negative 1 with positive 1 and its range is from 1 to t, because this point is not defined here. So we take this t. Okay, so let's break this. Okay, this is the first overlap and this is the second overlap. So the limit now is 0 to 1 for the first one, and this is 1 and this is also 1. So 1 multiplied by 1 dz plus the second one. Now this is negative 1. So negative 1 multiplied by this positive 1 and the limit from 1 to t, because this point is not defined, we don't know. And so taking integral, we get z here and minus z here and the limits. And then if we put the limits, here we'll get 1 and here it will be minus t minus 1. And so the final answer is 2 minus t. And now finally, we move it further beyond 2. So what is happening when we move it beyond 2? Nothing special. This one is overlapping. This one is also overlapping. But here there is no signal from HT. HT is 0, so we can't say that it is overlapping. One more thing to note now, that the overlapping limit is very, very clear now. From here the limits are from 0 to 1. There is nothing from here, we don't know, so we'll take these two limits. And similarly for this, it is now 1 and 2 because t has gone far away or away and it is not overlapping. So let's see, the movement is from t greater than 2. Two overlaps. Again this formula, original formula of integration. The limit we could have taken from 0, or we should take from 0 to t, but as we mentioned, that the overlap is between here. So from 0 to 1 is an overlap of positive 1 and positive 1. Plus from 1 to 2 there is an overlap of negative 1 and positive 1. And the third part, since this is 0, from 2 to t is 0, so there is no point of writing that, there is no overlap. So this is the limits, and if you solve, get this, and further solving this will give 0. Now let's summarize. So this is exactly same answer that we got in the previous video. For t less than 0, yt is 0, between 0 to 1, yt is t, 1 and 2, 2 minus t, and t greater than 0 is 0. And I had explained again how to plot this in the previous video. We'll just repeat. For less than 0, output is 0, so 0 line. Between 0 and 1, this is t, so you know y is equal to mx plus c. So here t has one slope, so this will be plotted against 1 and 1. So this is the positive slope, so t is plotted here. Now the between 1 and 2, it is 2 minus t, that means the t has a negative slope of 1, so negative slope of 1, and this 2 represents actually the y-intercept. So if you extend this, it will touch a point here at 2, so this is also plotted, and the last one, t greater than 2 is 0, so this is plot. So I hope this gives you an understanding how to solve this type of problems. Once you know the fundamentals, it becomes so easy. Thank you.